This is the Math 2 lesson summary video for Leapfrog. In task 6.3, Leapfrog, you will be provided with the pre-image and the image and asked to describe the transformation or series of transformations that could have occurred to produce the two congruent figures. The purpose of this task is to solidify the definitions of the rigid transformations, including translations, reflections, and rotations. By the end of this task, you should be able to describe translations, reflections, and rotations using the important characteristics of the rigid motion, as well as identify the transformation or series of transformations that occurred between two congruent figures. The first pre-image is image 1, and the final image is image 2. When we're trying to decide which transformation could have occurred to take image 1 onto image 2, we need to think about the properties of the transformations. When we look at image 1 and compare it to image 2, we can see that the frog did not turn or rotate. Additionally, we can see that the frog is facing the same direction. The frog did not flip. Since the orientation of the frog did not change, the students decided that a translation might have occurred. Some of the students selected a point on image 1, the pre-image, and located its corresponding image point on image 2. Many students chose this point on image 1 and mapped it to its corresponding point on image 2. Some students described the motion along the parallel line. Some students described the vertical and horizontal movement to map the point from the pre-image to its corresponding image. The students realized that the pre-image point shifted to the right 6 units and up 7 units. You can choose another specific point on the pre-image and map it to the image to verify. We can use patty paper to verify the transformation was a translation. We can see that image 1 was mapped onto image 2 by a horizontal movement and a vertical movement. We can also use the properties of a translation. If we find the slope of the segments connecting the corresponding pre-image and image points, we see that the segments are parallel. Additionally, we could use the Pythagorean theorem to find the length of each of the segments connecting the corresponding pre-image and image segments to show that the segments are congruent. To describe the transformation that mapped image 1 onto image 2, we need to include the type of transformation as well as the magnitude and direction. In our description, we need to say that image 1 was translated to the right 6 units and up 7 units to map to image 2. We can also write a mapping rule to represent the translation that occurred to map the input ordered pairs to the output ordered pairs. The second part of the task is to determine the transformation that occurred to map image 2 onto image 3. The students observed that the frog's orientation changed. The frog appeared to have turned or rotated. The students decided this based on their observations that the frog was now upside down, but also facing the other direction. The students proceeded to connect the corresponding pre-image points and image points. The students observed that all of the segments connecting the corresponding pre-image and image points intersected at a central location. All of the segments intersected at the ordered pair 1527. The students identified this as the center of rotation. Some students used a compass to connect the center of rotation at 1527 and the corresponding pre-image point and image point. The students recognized that the distance from the pre-image point to the center was the same as the distance from the center to the image point. The students also recognized that the corresponding pre-image points and image points seem to travel along an arc equivalent to half of a circle. Since each ordered pair of image 2 mapped to an ordered pair on image 3 by moving along a circular arc equivalent to half of a circle, the students described the transformation as a rotation of image 2 180 degrees about the point 1527. The third part of the task was to map image 3 onto image 4 using a single transformation or a series of rigid transformations. Students experimented with patty paper to try to figure out the transformation that could map image 3 onto image 4. Due to the change in orientation of the frog, students decided to look for a rotation. As they experimented, they discovered that a 90-degree rotation around a center point would result in image 3 mapping onto image 4. The center point is 1920. Students showed this rotation of the points along circular arcs using a compass. Some students also showed the segments connecting the pre-image point to the center, and as well as the center and the corresponding image point. This revealed the angle of rotation. The angle of rotation is 90 degrees clockwise about the center point 1920. Some students used a series of transformations instead of a single rotation to map image 3 onto image 4. Some students began by creating the segment that connected the pre-image point to its corresponding image point. The students used patty paper to translate the frog from image 3 along that parallel line. They translated the frog to the right 7 units and down 3 units until the pre-image point mapped on top of its corresponding image point. After tracing the translation onto the graph, the students used the point that corresponded as the center of rotation. The students then rotated the image 90 degrees clockwise around the center. Both methods that were illustrated are described in the table. The first transformation was a single transformation. Image 3 was rotated 90 degrees clockwise about center point 1920 to correspond with image 4. The second transformation was a series of transformations. Image 3 was translated right 7 units and down 3 units, followed by a rotation 90 degrees clockwise about center point 2422 to correspond with image 4. The next part of the task asks students to find a transformation or a series of transformations that can map image 1 to image 5. Many students observed that the frog appeared to have flipped and slid. This led to the development of a series of transformations. The students that had mapped the corresponding pre-image point to the image point using a translation proceeded with the same idea in this task. The students took this point on image 1 and mapped it to its corresponding point on image 5. They described this movement as a translation down 12 units and to the right 20 units. The students then traced the figure onto the paper and recognized that a reflection over a vertical line would map the frog onto image 5. In the table, the students represented the composition or series of rigid motions as translate image 1 down 12 units and right 20 units, followed by a reflection over the line x equals 27. The final pre-image to image mapping is image 2 to image 4. Like with the previous two examples, many students mapped the front middle toe of image 2 to its corresponding image point on image 4. Now that the front middle toes of the pre-image and the image are mapped to each other and overlapping, the students used that front middle toe as a center of rotation for the next transformation. Holding the front middle toe fixed as the center, the students rotated the frog 90 degrees counterclockwise until the frog mapped onto image 4. In the table, the students recorded the series or compositions of transformations that occurred to map image 2 onto image 4. Translate image 2 down 7 units and right 11 units, followed by a 90-degree counterclockwise rotation about center point 2422. At the conclusion of the task, it is a good idea to review the bulleted list of important characteristics to include when describing a translation, reflection, or rotation. This bulleted list is found at the beginning of the task. For a composition of transformations, or series of rigid motions, describe the movements in the order that they occurred. For a composition of transformations, try mapping one specific point from the pre-image to the image using a translation. Once the corresponding points are mapped on top of each other, complete the next necessary transformation to map the entire figure onto the final image. This concludes the summary video for Leapfrog. If you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.